So just to make sure everybody's on the same page, you know, we're jumping in and talking about the system development and specifically software development. And I just went in and talked about the object-oriented programming. Just to break it down a little bit more, you can take a look at the screen here. So the object is down here, right? And if we just kind of have this step or the stairs right here, right? The object is the lowest component. The object makes up classes. So as we kind of move up here to the next step, n number of objects can make up classes. Classes can have inheritance, which is when you can get properties from other objects, which is kind of cool. So if you wrote a piece of code, I can call your code to populate my object and inherit, so I don't have to rewrite code from scratch. This word right here, polymorphism, that sounds like something out of the X-Men, right? But we can take an object and make it do a bunch of different things. So, obviously the word, for anybody who's a wordy that's out there, would be having many forms, right? And the same thing goes with programming. Polymorphic is having objects being so abstract that you can fill the object with just about anything. And if you write it in a way that is clever enough, then you can absolutely do that. Sometimes polymorphism is kind of tough, though. In addition to that, then builds upon there, and we can have different types of data within an object, and giving us a layer of abstraction. And then finally, being able to encapsulate the information we're binding the data to prevent any external interference is another technique that typically you will see in object-oriented programming. Let's take a look here at this this diagram that I have. So an object can instantiate a class, right? An object can instantiate a class. So there's n number of objects in a class, or you can just have objects. You don't necessarily need to have classes, but typically we do. And so that class invokes a bunch of different objects. We can have a bunch of different objects in it. And if I have object A here, and object A is, just a part of a program, what I can do is in the program, I can have and send different messages to any of the other objects within the program. So it almost is like at runtime, when I run this program, this is almost like it creates a mesh in between each and every one of these objects that allows them to interact with each other, which is kind of cool. And if you've never done this before, it's kind of neat. But the idea here is that you need to make sure that whenever you are programming, you're able to interact in a way that's meaningful. And each one of these objects maybe has, n number of methods that will produce different types of data. And as they're interacting at runtime in RAM or in cache or in session objects or in memory, it's important to know that a lot of the different ways that programs interact is exactly like this right here. And the idea or the notion of it would be as follows. So if I have, for instance, in my the way my silly mind kind of works. Let's say here that I'm looking to have a program that ultimately picks a car for a person or helps a person pick a car. Well, how would I do that? And why is that important? Well, one object, we'll just call it object A over here, is the make of the car, right? The quote unquote make of the car or the vehicle. So is there a certain type of car that you like? What's another one? Well, I might have the model, right? Do you like the Model Y or the Model S or, whatever Tesla you like to drive? Down here, you guessed it, the color. Like, what color do you like? And then over here, these different objects, right? I'm just being silly with some of these objects. So for brevity purposes, just go with me here. And then over here, what bling bling do you want on it? Right? Maybe we actually create an object that's called bling. And any programmer that's reading your source code would look at it and get a little chuckle out of it, right? And I always do that. I always comment my code and put a little Easter egg in there because we're all just trying to have a little bit of fun. And so the sum of the whole here, and there might be 50 to 100 other objects that we can create for this program. The sum of the whole would give us the year, the make, the model, the color, the bling bling. We could get into tires, we can get into rims, we can get into window tint, convertible, we can get into the stereo system, which is important. Seat warmers, my goodness, we could go down a rabbit hole when we're creating this program. And maybe I should give you an assignment to create something like this for homework. I'm just kidding. That would be fun though. And so, when you go in and do this, there's a bunch of moving parts. And so with these moving parts, we need to make sure as security engineers, because we're not software engineers, or at least for purposes of this exam, we're not software engineers. We have to make sure that we test this junk out, right? We want to test this stuff out because there's all sorts of things that can happen. You remember the idea of the TCSEC, if you recall, that was the trusted computing for, if you remember, the TCSEC that we talked about, the Orange Book. It actually went in trusted computer system evaluation criteria. It talked about the life cycle assurance. And so in the life cycle, you made a big deal in software development security is software assurance. And so typically we'll run different programs to help us find holes in people's software. And so this is a whole discipline in itself, software assurance for security professionals, that will allow you to be part of that lifecycle assurance if you follow the ways that you need to do security code reviews and the like. But there's, system failures could be a big problem. Input validation and validation of user input. Remember, that's kind of what the Clark Wilson gets into and starts to talk about. The authentication and session management. So making sure that different data is not, remnants of data is not from code to code. Any error handling, making sure that we log. And that's one of the saving graces in every program that I've ever been involved with. Even weapon systems, doing evaluations on weapon systems. If I can find the log file, it's likely that I can get literally the keys to the kingdom on any system that is meaningful. So at a high level, just understand that's typically how object-oriented programming works.